video is going to be on how to solve systems of equations algebraically. So here we have a system, and this is written a little differently than what you've seen before. The previous ones, we already wrote them equal to one another. So here we have y equals x minus 3 and y equals 4x. First thing we need to do is to set them equal to one another. So we're going to say x minus 3 is equal to 4 divided by x. Next step, we need to get this into standard form. So I'm going to make the left-hand side a fraction. So we've got two fractions equal to each other, and we're going to cross multiply. So I've got x times x minus 3 is equal to 1 times 4 is 4. From here, I need to put it into standard form. So we're going to start by distributing in this x. X times x is x squared. X times negative 3x is equal to 4. And to put it in standard form, it needs to be set equal to 0. So I'm going to subtract 4 from both sides. And we have x to the second minus 3x minus 4 is equal to 0. So what we're trying to do here is we're trying to first solve for x. And we're trying to find, our ultimate goal is to find where these two equations intersect one another. And those are our solutions. So to get x, you know how to do this. We've done this before. We're going to factor. So I'm looking for two numbers that multiply to negative 4 and that add to negative 3, which are negative 4 and positive 1. So in factored form, this is x minus 4 times x plus 1 is equal to 0. To solve for x, I'm going to take each binomial and set it equal to 0 and solve for x. So here I need to add 4 to both sides. So one of our x values is equal to 4 and the other is equal to negative 1. Now, in the past, when we've solved quadratic functions by factoring, we stopped here because we were looking for the x-intercepts. And we always know that with an x-intercept, our y value is always equal to 0. Well, I'm no longer looking for the x-intercepts. I'm looking for where these two equations cross one another on a graph. So I also have to find the y values. And how we're going to do that is we're going to take each of these x values and we're going to plug them into each of these original equations and see what y is equal to. So let's start with the first one. So y is equal to 4 minus 3. So that means y is equal to 1. And on the other equation, I need to see if that's also true. So y equals 4 divided by 4, which is also equal to 1. So one place that these two graphs intersect is at x value of 4, y value of 1. So now I need to go over to the x equals negative 1 and do the same thing with those two equations. So y equals negative 1 minus 3, which is equal to negative 4. And let's try the other equation. Y equals 4 divided by negative 1, which is also equal to negative 4. So the other solution is negative 1, negative 4. And now we've just solved this system algebraically. Next example, we've got a quadratic function and a linear function. So again, they're written as two separate equations. So what we want to do is write them equal to each other. We're basically just dropping this y equals part. So we're going to do x to the second plus 2x minus 20 is equal to 2x plus 5. Next, I need to get these into standard form. So I need to get one side set equal to 0. So I'm going to start by subtracting this 5 from both sides, and it's going to get combined with the negative 20. So x to the second plus 2x minus 25 is equal to 2x. Still need to get this set equal to 0. So let's minus 2x on both sides. 2x minus 2x cancels each other out. So on the left, we have x to the second minus 25 is equal to 0. So now I need to solve this. I need to find the values for x that make this equation true. So I am looking for two numbers that multiply to negative 25, since that's our c term. Notice our b term canceled out here, so b is equal to 0. So two numbers that multiply to negative 25 and add to 0 are negative 5 and positive 5. So factored form, we've got x minus 5 times x plus 5 equals 0. And here, x values, x equals positive 5, x equals negative 5. So now I need to do like we did on the last one, and I need to take these two x values, plug them into each of these equations to find what y is equal to. So the first one, we've got y is equal to 5 to the second plus 2 times 5 minus 20. Simplify that. That's 25 plus 10 minus 20. That's 35 minus 20. So y is equal to 15. And I'm going to try it in the second equation just to make sure it's also true for that. Y equals 2 times 5 plus 5. Y equals 10 plus 5, which is 15. That one is also true. So one point where these two graphs intersect is at positive 5, 15. And now I want you to take this x equals negative 5 and plug it into both of your equations, see what y is equal to, then come back and check your answers. So our second point of intersection, when you plug in negative 5, you should get negative 5 for both y values. So the steps we took, just to summarize, first thing you need to do, if your two equations are not already written equal to each other, you need to set them equal to each other. Get them into standard form. Just get everything moved to one side, set equal to 0. You might have to cross multiply if you have that inverse function on one side. Next, you want to solve for x by factoring, where you could use the quadratic formula. That will work also. Once you get those x values, remember you have to go back and plug them into each of the original equations to figure out what y is equal to. And then the x value that you found from 3 and the y value you find from step 4, those make up the coordinate for where the graphs intersect.